Are you able to hear me? Great. I can see Mahesh, Mohammed, Piyush, Tanup. What about others? Are you able to hear me? Abhinav? Thanks, Abhinav, for joining in. Thanks, Vivek. Thanks, Mubin. Thanks, Pramod. We are just starting in a couple of minutes. So before that, I just wanted to make sure that everybody is able to hear me. So what about others? Are you able to hear me? Yeah, Rahul. Thanks very much for joining in. Hello, Ritesh. Thanks, Naveen. Hi, Gaurav. Thanks, Sunil, for joining in. Thanks, Vimal. Okay, so let's get started. So I can see another one. Okay, so Henry, thanks Henry for joining in from Peru. Okay, so let's get started. Before we get started, so this is like from where our journey of cloud computing starts, and some more details here, like our website as well as our email address. So we will be sharing these details with you, so that's okay. Before we get started, just wanted to have a quick apology from my side because you got multiple emails and it was not our problem, but there were some problems with the WebEx email servers. So really a sincere apology from our team, our whole NanoCell team, because of some issues with the WebEx email server. You got a lot of emails, somebody got 10 emails, somebody got 10, 12 or 15 emails as well. Sorry for flooding your inboxes, and I'm really apologize for that. And let's move forward. Some important hacks for this session, some important things to follow. So just try to keep your mobile silent or on vibrate for 90 minutes, so you will be able to get best out of this session. Interactive session, so feel free to ask questions. So we are all here to interact. We are not here to speak and listen. So please feel free to ask questions. However, because we have a larger audience, if you have a question, reserve it at the break or end. We will be taking some logical breaks after 10-15 minutes. And at the end also, we will take questions. Somebody is on, Mr. SC is on mic. Can you please mute your mic, Mr. SC? So, if you have any questions, please reserve it till the break or the end. We will be taking up these questions during the breaks and or the end. Or you can keep typing your questions in the chat box and I will take those questions during the break. Recording of the session will be available. So whoever has joined in, and I will be sharing the recording of the sessions with you. So you will be able to go through the session if you have missed anything. Feel free to take notes. If you have anything important, please feel free to write us. We will be able to take it up. So if you need a copy of this presentation, you have to fill the feedback form. At the end, we will be sharing some feedback form link, and you have to fill the feedback form. And we will be sharing the presentation, a copy of this presentation with all the people who will actually fill the feedback form. And we actually appreciate both positive and negative feedbacks. So feel free to give your feedback, whatever you feel like, whether it is positive feedback or negative feedback. Now, what we are going to learn in this session, so we will talk about it, why cloud computing. The cloud computing is important for technology professionals. I come from telecom background, and telecom industry has taken it like a wave, right? So it completely changed. So we'll understand from the telecom perspective also, but in general, we will talk about why cloud computing is necessary for any technology professionals to learn and understand. We will understand how we can move to the journey of the cloud, IT, which was considered as local infrastructure, and how we are moving towards global infrastructure. We are going to talk about it. 5 characteristics of cloud computing. We will talk about 5 basic characteristics of cloud computing. We are going to talk about. We are going to talk about 3 service models, which are typically IaaS, PaaS, and SaaS, which is infrastructure as a service, platform as a service, and software as a service. We are going to talk about 4 deployment models of cloud computing, which are typically public, private, community, and hybrid deployment models. We are also going to talk about how cloud is transforming next generation telecommunication network. So we'll talk briefly about telecommunication network and how cloud is actually transforming these networks in a big way. and finally, we will have summary and the recap of the session. I hope you are all able to hear me clearly. So if you joined late, I again apologize for all the emails what you have received. There were a flood of emails in the inbox of yours. So it was all happened because of some WebEx email server error. It was not a problem from our side, but still our sincere apology for the same. Now, cloud computing is bringing in the biggest technology revolution around us, and it is changing the way how IT infrastructure is being delivered, how services are being consumed. It is changing all the business models, whether old or new, and it is changing the way how applications are being run and delivered. It is bringing in new opportunities for all the old and new businesses, as well as where your data is stored somewhere in the cloud. What is the meaning of the cloud? We'll understand in the next few slides. All we are using is cloud-based services which can be accessed from anywhere in the world. So we have this technology revolution happening around us, where all the business models are changing, especially in industry like telecom, which is like taken completely aback by the cloud computing market. So now the complete telecom infrastructure is moving towards cloud. So we'll talk about all these things, and we'll go all those things one by one. What we are going to talk about, what are the different technology parameters we need to discuss about the clouds? What are the different market options we have available when we want to talk about cloud? What are the business value it brings to the customers? What are the opportunities and the challenges, basically the risk? So cloud comes with a lot of risk also. We are going to talk about what are the risks involved when you want to deploy your workloads on the cloud infrastructure. Now, who should learn this? Almost everybody who works in high-tech industry, whether it is telecom, IT, or any other industry, pharma, aviation, hotelier, any travel industry, any industry you're working with, you have to have some connection with high-tech. You should learn cloud computing. Of course, everybody cannot be an expert in cloud computing, but yes, you should learn at least at basic level. And hence, we have created this program. This is overall an overview program which anybody can understand, and we will be coming up with so many detailed programs as well. Now, this is me. My name is Sanjay Kumar, and I have 18 plus years of work experience in telecom, IT, and cloud industry. I have 12 plus years in training and teaching. I have trained more than 10,000 students in 50 plus countries. I'm an AWS certified solution architect, and I'm a cloud and AWS trainer and consultant. However, this learning cloud computing is a big road ahead, and this is just the starting point of us. But somehow we have to get started so that we can reach to the bigger milestone. Again, don't get panicked. If you're not able to understand anything, we will be able to take those, you will be able to understand those things in some other sessions. But yes, this is just the starting point to start learning AWS or cloud, for example. So we will just start with cloud, and then we will move on with some future sessions where you will get a lot of other information related to the cloud computing. So before we get started, let us understand what is cloud computing. Few years back, how the IT infrastructure was delivered, where we had the hardware infrastructure, which is typically this infrastructure available in the corporate offices, which are typically called as on-prem data centers or in-house data centers. All the platforms were also developed by the customers, and all the services were also deployed by the customers. So the complete architecture was managed by customers. And to access that network, you have to be in the corporate network and connect it locally or through some VPNs. So you have to connect it either locally or through some VPN connections to configure these devices. And everything was your responsibility, whether it is related to the physical security or the real estate or the power connection or the air conditioning unit, and also related to the IT infrastructure. Sorry. IT infrastructure related to the servers, compute, storage, and everything. Also, anything related, just give me a second. Okay, sorry for that. So anything related to the platforms, the runtime environment, operating system, and anything related to services, each and everything has to be deployed by the customer itself. However, in the cloud environment, all these infrastructure, all these platforms, and all the services, they are all hosted in a cloud environments. We will understand what is cloud environment, and what we need to do is we need to access this cloud environment by using internet, and this can be accessed from any device from anywhere in the world. So you can access these resources from any device and anywhere in the world. So this cloud infrastructure is globally available. We call it global infrastructure. So it is globally available and we can access it from anywhere in the world. And also it allows us to access these resources by various means. What are those various means? We are going to talk about. Now, what is cloud computing? In simple words, as a layman, what I say, in simple words, it is nothing but a computer or server which is remotely hosted. So if you want to keep it simple, the cloud is nothing but a computer or server which is remotely hosted and which is available for the end users to configure their workloads. However, in technical words, it is a collection of large computing environments which are typically called as data centers, which is nothing but a shared pool of resources and can be provided with a on-demand model. So that means the data centers are nothing but a pool of n number of servers, and they are available with the end user. End user here is not the person who is actually using those services, but actually deploying those services. It is basically the company who is deploying these services is considered as end user, and it is available in on-demand model. Now, what are data centers? Data centers are huge collection of computers and servers. So you will see big computers and servers which will have almost infinite capacity. So when I say infinite, no server will have infinite capacity, but according to the usage, they have created n number of different servers and huge data centers which can offer a almost infinite capacity. So it is always available, all the time it is available, and it gives you high durability, high availability. That means your resources are always available. You can access these resources as and when required. Now, according to NIST, which is National Institute of Standard and Technology, what is cloud computing? So cloud computing is a model of enabling ubiquitous, convenient, on-demand network access with a shared pool of configurable computing resources, and these resources can be networks, servers, storage, applications, services, and many more. And this can be rapidly provisioned and released with minimal management effort or service provider interaction. So typically, this is nothing but a shared pool of computing resources which is available for the user without any intervention from the cloud provider. For example, if you want to allocate some resources from AWS, you need not to speak to anybody. You can simply log in into their portal and allocate whatever resources you want. Typically, cloud model is composed of three things. One is 5 essential characteristics. We are going to talk about it. 3 different service models and 4 different deployment models. So we are going to talk about all these 3 things: 5 essential characteristics, 3 service models, and 4 deployment models. Now, what are the benefits what you get from the cloud? Supply and consumption of IT infrastructure virtually. You need not to have any physical infrastructure. All these resources can be given to you virtually. On-demand data centers, on-prem traditional data centers are now moved to virtually hosted environments, which will have state-of-the-art features and services. The kind of features and services you can have in public clouds, you cannot even imagine to have those features and function in your on-prem data center or your private clouds, because they are serving millions of customers. We can't even imagine of having those features and services in our own data centers. Services can be subscribed on demand. On demand is one of the main features of cloud, and you can use it whenever you want. You can release these resources whenever you don't want it. Pay as you go. You only pay for the services or the functions or the infrastructure that you use, and only you need to pay a certain amount. And after that, once you release these resources, you need not to pay for these resources. Data centers are owned by and operated by public cloud providers like AWS or companies. We are going to talk about those things. Go global in minutes. So you can deploy global services typically in minutes. Time to market, because you can create global services in a minute. Your time to market for new services is extremely low. And this is coming up as a game changer in the IT industry and getting very popular with exponential growth. So if you are working in any high-tech industry, learning cloud is very important for all of us. If without learning cloud computing, we cannot really grow in our jobs and in our businesses if we are related to anything related to technology kind of business or jobs. Now, what can be cloud computing? I can have a need of virtual servers. So I need some infrastructure with 16 vCPUs and some 250 GB storage. This is one example. And I may need some applications which can be easily deployed. For example, some machine learning services or some translation services. And if I want these services to be deployed across regions, I may need to translate my website content. So that also can be ready-made services available on public cloud. And also, I may use it only to store my excess data. So I have a on-prem data center and I want to use this public cloud, just to store my excessive data, which is like in hundreds of terabytes. So I can release these resources whenever I can use these resources whenever I want, and I can release these resources whenever I don't want it. Now, what are the typical applications? So from last few months, we are all working from home and we are all aware about these applications, which you have not heard few months back. So it can be Zoom, it can be Google Classroom. Our kids are attending their classes from Google Classroom. We are storing files on Google Cloud, Google Drive. We are using WhatsApp. We are using YouTube. We are watching videos on YouTube and Google Meet. So some of these examples are various services of cloud computing. Typically, anything and everything what we are using on the internet today is somehow related to cloud computing, if not directly. So all the services that are being used, they are somehow related to cloud computing. So leading cloud service providers, if you name the leading cloud service provider, AWS is one of the market leader for cloud. And another one is Azure, which is Microsoft Azure, the Google Cloud, and the fourth one is Alibaba Cloud. So this course is about cloud computing, but we are soon very soon coming up with on our YouTube channel with more courses where we will talk about AWS in English, and for some regional people in India, we are also coming up with courses in Hindi as well. So AWS, Azure, and Google courses we are coming up on YouTube channel. So you have not subscribed to our YouTube channel. So my colleague Kuldeep will be sharing the link in the chat box. So please like and subscribe our YouTube channel, and you will be getting all this content for free in our YouTube channel. If you have any question, any feedback, any comments, feel free to write in our YouTube channel as well as you should be able to write it in our feedback form as well. Now, if you look at the Gartner MQ, so Gartner every year releases something called as MQ, which is called as Magic Quadrant, where they define leaders, challengers, visionaries, and niche players. So we talk about this. AWS, Amazon Web Services, is the market leader from last 10 years. So actually, I'll say more than 10 years. And AWS is actually leading this from last more than 10 years. And it has got a market share of almost 33% among thousands of cloud providers. And if you look at the first three, which is AWS, Microsoft, and Google, they actually have more than 50% of market share. So all these three have more than 50% of market share. And all these reports are Q2 of 2020, which is by Synergy Research Group. And this is the Gartner MQ, which is typically the Gartner Magic Quadrant. Now, number one, AWS is the number one in market size as well as market share. Now, AWS, if you look at this, just to give you an example, the pace of innovation, which you can never have in your on-prem data centers. Every week, they are coming up with new services. So as of now, they have more than 6,000 services available. So I'll not say services, they call it services and functions available in AWS Cloud, which we cannot even imagine in our private cloud or on-prem data centers. So every week you open AWS console, you will see some new features and functions available. So it is changing at a pace. So this technology is like catch me if you can. So you have to evolve every day and you have to learn about these things. So AWS has got a lot of machine learning, ML services as well, which is getting very, very popular at this stage. So this is just to give an example how vast is this cloud. So it is not possible for anybody So hardly there will be anybody in the world who knows all the services. Even in AWS, there will be hardly anybody who knows all the services of AWS. But yes, there are some basic services we should all learn if you're working with the technology industry. Now, moving from local to global infrastructure. So traditional IT, which was always a local infrastructure, where you had on-prem data centers, where you had in-house expertise requirement to maintain and operate. So you need to have some teams who can manage the hardware, who can manage the platform as well as the cores or the applications. And because this was typically managed by a certain team, the time to market was very slow. It takes huge time to actually market your new services, and it comes with high capex and high opex. So we want to actually resolve all these problems, and that is the reason we are going back to the public cloud infrastructure. So we want to reduce the cost. The cost is the prime motivation to move to the cloud infrastructure. How we can minimize our costs. So if you set up your data centers and have your teams to manage those data centers, the capex is going to be high. At the same time, opex is going to be high as well. But in the case of cloud, your capex can be zero. So you're starting with absolutely no infrastructure, and you can increase your capacities as and when you require. And it also reduces your opex requirements as well. We are going to talk about some of these things a little bit in detail in the next few slides. Now, moving to global infrastructure, if you look at this is picture taken from aws.amazon.com. So if we look at 24 regions, so they have launched 24 different regions where they have 77 availability zones. So we will not talk much about availability zones. For that, we are coming up with another session on AWS. We will be talking about all these things in that session. And they have got 216 point of presence, which is typically called as edge location or edge caches, which are nothing but something called as CDN, stands for Content Delivery Network, which is used to bring the data center closer to the end user so they can have enhanced consumer experience. And they're, as of now, they're serving 245 countries and territories. So if you see, having a on-prem data centers in your own office and having an infrastructure across globe, that is something what benefit you're going to get from the public cloud infrastructure. You can have an office in India, but you can have your customer base across United States. So you can simply, instead of deploying your services here, you can actually deploy your services here where you have all your customers coming in. So it is not mandatory to deploy your services in your own office. You can deploy it wherever you want and where is your consumer base. And at the same time, you can also deploy your services here as well as here. So the people who are accessing your services from this are accessing this resource, and people who are accessing resources from here, they will be accessing your services from here. So the latencies and the consumer experience can be improved if you are going with the public cloud infrastructure kind of stuff. Now, moving on with the typical characteristics of the cloud, 5 different characteristics: on demand, self-service. So the services are available on demand and they can be self-service. So you can access these resources whenever you want these resources, and you can configure, you can maintain, and you can release these resources whenever you don't need it. You need not to have a single discussion with AWS. If you have the good understanding of the platform, you need not to talk to anybody and you can configure your workloads. And there are huge amount of resources available which can help you to create your workloads automatically without getting in touch with AWS. And that is the biggest reason of, if you really need to go to AWS and buy something, that is something which kills the whole idea of public cloud. So because they are available on demand and because they are available with self-service, this is the biggest benefit what you have from the cloud infrastructure. Broad network access, we are going to talk about it. That means your resources can be accessed from anywhere in the world with any kind of device. Multi-tenancy and resource pooling. The cloud infrastructure is created with the pooled resources and they support with multiple tenants. Of course, if you need some dedicated services for you, they can do that as well. But this is something called as EOS. EOS stands for economics of scale. How public clouds are making money because they are serving millions of customers instead of serving only one customer. Right. So that is the reason resource pooling and multi-tenancy becomes very important characteristics of cloud. Rapid elasticity and scalability. Your resources can be increased and decreased at any point of time. So you can release these, create these resources, and you can release these resources whenever you want it. And if you don't want to do it manually, they have some policies which you can create, and this can be done automatically as well without having any human intervention. So major services, because I have to access these services, and I have to pay for these services. These services are metered or measured so that they can charge you either on per second basis or per minute basis or per hour basis, or they can also do this depending on how much storage you want, what kind of capacities you want. And the new concept which is coming up in the cloud infrastructure is called as serverless. Serverless is something which is very new to the cloud infrastructure, and that means you absolutely need not to have any server setup. So whenever there is a trigger, this can activate a server, and you only pay for the triggers or for the processing capacity which is being used. So you really need not to have any server setup. Serverless, so for example, just to give an example, a company which was using some serverless technique, if they don't use serverless technique, they have to spend almost USD 10,000 per month. But by using serverless, their monthly bill of cloud infrastructure is 300 USD. So they are saving a huge cost by using serverless technique. So serverless is very important and very new feature coming up in cloud environments. And very soon you will not have any need to set up servers or some cloud infrastructure. You can simply create your database, your workloads on serverless architecture. Somewhere it is also related to something called as microservice architecture. We will not get into those details as of now, but we will have a separate session to do that. Now, let's talk about what is on-demand self-service. A consumer can provision these cloud resources and can go global in minutes. Some of these resources can be some server capacities, some unlimited storage, any services what you want to deploy, auto scaling and load balancing. You can increase the capacity and you can decrease the capacity whenever you want. And you can simply send some configuration requests, and there is a framework which is created for self-service. What is self-service framework? We are going to talk about. So self-service framework will allow you to create these resources whenever you want. Now, these self-service resources can be some web-based GUI portal. So there will be graphical user interface portal. You can simply log in and you can simply configure these resources. If you're not done so, please look for free tier of AWS, which allows you to experiment with AWS for free. But make sure you understand the conditions very clearly, because this free comes with a question mark. Otherwise, it can charge you a bomb. So you have to be very careful when you are actually using free tier of AWS account. So you have to be sure what actually you're using. So it can be a web-based GUI portal. You can also access these resources by using some command line interface tools, CLI tools. You can do it with a command line interface. You can also do it with RESTful APIs. If you're not sure about RESTful APIs and all, no, don't worry. It is called as application programming interface. We will have another session where we will talk about all these things in detail. And we have something called as SDKs, which are typically software development kits. So these are the multiple options we can have to create these resources on demand and by using self-service. Now, broad network access, we will talk about it. It can be accessed from anywhere, and also it can be accessed from mobile phones, laptops, desktop, etc. So you can have all these resources. You can access these services, platforms, infrastructure from anywhere in the world by using simply an internet connection. We can also modify, monitor, and add, change, or delete these resources at any point of time from anywhere. And it also comes with a lot of features. So it gives you a lot of security features as well, how you want to connect to these resources. Now, resource pooling, as we talked about it, there are n number of servers, and we have seen a picture where n number of servers are pooling together, and they're all virtualized by using some hypervisor, which can be related to compute, storage, or networking. And every virtual machine can have their own operating system, can have their own applications, and can have their own virtual machines. So we are just using the virtualization and the resource pooling to create our cloud resources. So we'll have a couple of more slides and then we'll break for some questions. Now, rapid elasticity. So capabilities or capacities can be elastically provisioned and released. So you can increase the capacities whenever you want, and you can release these capacities whenever you don't want it. And in some cases, they can be done automatically as well. So we can increase outward as well as inward. And to the consumer, they only pay for the services what they'll use. So it is appears to be for end user, it looks like it is unlimited and it can be created at any quantity at any point of time. So it is basically available for the end user, and users will feel that it is almost unlimited and they can create it for user at any point of time. Now, how it helps me, it minimizes the cost of resources of not being used. So typically, the resources for what we are not using, we will not pay for that. What is the meaning of that? We will talk in the next slide. And we can increase the capacity for a spike in traffic. So whenever there is a traffic spike, we can actually increase the capacity whenever we want it. And we can also quickly market new services. Now, if we look at the fixed capacity or on-prem data center, where we have assigned the capacity more than the peak demand. So this is our peak demand here, and we have defined the capacity more than the peak demand. Now, in this case, typically, on-prem data center waste 70% of the resources. That means 70% of the resources are being unused for on-prem data centers. So almost 70% I'll say, but they are actually greater than 70%. So whenever you go with fixed capacity, you actually lose 70% of your resources. So you actually you pay for them, but you don't use them. Now, rapid elasticity helps me to follow the trend of the demand. So I can increase the capacity and I can decrease the capacity whenever there is a change in demand. So I actually follow the pattern of demand, and I can pay, I can increase or decrease the capacity whenever I want, and I only pay as you go. So that means I only pay what I use. I don't pay for any excessive capacity. So I have to be very sure what kind of services, what kind of deployment. Of course, even in cloud, you can have these environments. Even in cloud, we have seen some companies who were building infrastructure where they have defined capacities more. You can also waste these kind of resources in cloud environments also. That is where solution architecting comes into play. So using cloud is not the only solution. You have to deploy your resources according to the best practices available in that cloud environment. So architecting your network, architecting your cloud infrastructure is very important. And one of the major certification in all the public clouds is about solution architecting, how you architect your cloud services. So that is one of the very important aspect of public cloud infrastructure. Major services, and we only pay for the services that we use. These services can be server capacities, how many virtual CPUs and how much RAM we are using. It can be operating system, can be different for Windows as well as Linux. It can be dependent on location and region. So if you want to store your data in US and if you want to store your data in India, the pricing can be different, and it also gets affected by n number of different parameters. Type of storage and capacity, and you can also choose to have what is the kind of high availability you need for your storage, what is the durability you need, what is the accessibility you need. Depending on that, you will have different storage tier. So for example, most of the cloud provider have multiple storage tier where you can define how you can also define a life cycle. After a certain period of time, the data will be moved to another tier where you will have less cost. And after a certain period of, let's say, 12 months, the data will be automatically deleted, either moved to archive or it will be deleted. And the cost for every tier is going to be different. And bandwidth consumption, how much bandwidth you're consuming, that will also affect your cost. And also what kind of support you need from the public cloud provider. So these are not all, but some of the major parameters based on which you have to pay for your services. And number of requests you are having for your workloads for read and writes. So these are some of the parameters which will impact your cost using public cloud infrastructure. Now, before we move to the next slide, let me ask if you have any questions, any comments here. Let me have a look at the chat box. So if you have not not subscribed to our YouTube channel, so we have a YouTube channel with Cloud Training Guru. The link of that is given in the chat box. You can actually subscribe to that channel, and we will be coming up with a lot of other sessions. Yeah, if you have any questions, please feel free to unmute your mic and ask those questions, or just type that question in the chat box. Any questions here? Any questions, comments, doubts? Okay, no questions. Let's move forward then. So we have three different service models. We typically call it as infrastructure as a service. In case of infrastructure, you are just getting the physical infrastructure for your services, whether it is virtual CPUs, RAM, storage, or networking. So these are the various resources what you have to deploy your services. So you simply deploy your platform. Okay. So there is some question related to the certification. Vivek, we will take this question at the end of the session. We will talk about multiple certification, and we will answer your question at the end of the session. Okay. So you simply need to move these infrastructure, move your platform and services to these infrastructure. Platform as a service, where you actually get the platform as well as the underlying infrastructure from the cloud provider. It may be app development, runtime environments, integration, or OS images. And software as a service, which is typically notification, queuing, SMS, emails, workflow, and number of other services which are available, which you can directly go ahead and use it. So you really need to understand what actually you want from the cloud provider. Either you need the infrastructure, or you need the platform as well as the underlying infrastructure, or you directly need some services from the cloud provider. So typically, it is up to the customer to decide what they actually want from the public cloud. Now, infrastructure as a service, which is typically providing computing resources, storage resources, and networking resources, and all those things are provided virtually. Platform as a service, which provides frameworks and platforms to develop softwares and applications. And software as a service, which is providing services which are end users. So we can get all these services, either infrastructure as a service, or platform as a service, or software as a service, and they have n number of services available in each category. So it all depends on the end customer, what they actually want from the public cloud provider. Now, what are the different deployment models we have for the cloud? We have public cloud, we have private cloud, hybrid cloud, and community cloud. So let's talk about those things one by one. So private cloud, actually the on-prem data center, which is actually virtualized and used by one organization and internally available for that organization only. So we can have a big organization which don't want to rely on public infrastructure. So they can actually go for private cloud and their own infrastructure. So that is something possible in private cloud. However, if I want to have these services available for anybody and everybody, I can go for public cloud, which is available for each and every person, and they can configure these resources depending on their requirement. However, I can also have a hybrid model where I can have on-prem data centers. At the same time, I can access cloud resources for my extension, my extensive requirement. If I have more requirements, I can simply go for hybrid environments. So where I can have my on-prem data center as well as I'm using public cloud. The community cloud is created for some community specific requirements. It can be related to health, social welfare, or some government related cloud. So they all come under the category of community cloud, which is not mentioned in this particular picture. We have four different models, deployment models, which is public, private, hybrid, and community cloud. Now, moving on, if you look at this 2G to 3G or 4G core versus 5G core, so telecom networks have been seen a bigger transformation. So telecom network has seen a bigger transformation in the new technologies. If you look at all 2G, 3G, and 4G core networks, they were all hardware-based network elements. They were all dedicated core networks. So we had specific core networks for 2G, 3G, 4G networks. They were all functional entities and they were all using proprietary protocol and they were not scalable. However, moving towards 5G core network, we are having completely cloudified and softwarized networks, absolutely no hardware-based networks. We are using virtualization and slicing kind of parameters, where we are actually using virtualization and slicing kind of techniques, and where our architecture is based on the services. So our base architecture is based on the cloud, and we call it as service-based architecture. All the interfaces are supported with API, which is application programming interfaces, and we have all the protocols which were earlier proprietary protocol, and now they are moving towards all HTTPS and JSON based protocols, and this also gives exposure to the third parties. So we have a lot of functionality and features available which were not possible in earlier generation, but we are able to achieve all these things in 5G core network. Now, if we look at this 5G core network architecture, we have n number of services available. If you look at this, all these functions, AUSF, AMF, we have a detailed sessions on all these topics. And if you want to access those sessions, you can simply join our NanoCell YouTube page, which will have all the resources available for these topics. So all these blocks, what we see here, they are not actually the machines. They used to be machines till 4G. In 5G, they are all created software blocks. So they are basically virtualized network functions. We typically call them VNFs, and all these VNFs are created in the cloud infrastructure. So we only need to have the antenna part of it, which is connecting towards user as a hardware, and everything else can be softwarized in the cloud environments. So it is all cloud environments, and all these services are being used in cloud environments. So we have all these services available completely in cloud, and we all have this thing available in the only thing which is available as a hardware is the antenna part, which is serving the end customer. The radio waves which are being transmitted to the end user is only the hardware part of it. Rest everything can be customized. Everything can be softwarized according to the requirement. Now, what are VNFs? So typically we have cloud environments, and we can create something called as, we have something called as virtualization, which is also called as NFV, network function virtualization, which can actually decouple network functions from the hardware, and we can create all the network functions as virtual network function, and it can be deployed on and only like customized off the shelf hardware. So it can be deployed on any CORS kind of hardware. These can be stateless and can scale on demand, and this can design to run on cloud, which is like VMs or containers. So we can actually create all our VNFs, all our virtual network functions on virtual machines, and something called as containers. So container is a new thing which is there in the cloud, so where we can actually pull in lot of virtual machines and can create some containers. So network elements which were earlier available only on dedicated hardware, and now they are all available as VNFs, which are typically called as virtual network function. And the procedure of creating these VNFs is called as NFV, which is typically network function virtualization. So we have VNFs, virtual network functions, which are created using something called as NFV, network function virtualization. So this is all for this session, and I think we have finished pretty earlier than the design time, but that's okay. So we will have a quick recap and summary. Why cloud computing is requirement for cloud computing is important for technology professionals. So it is very much required because the whole IT infrastructure is moving towards cloud. All the new services, all the new networks, all the new new businesses are actually built on the cloud computing. So cloud computing is very important for technology professionals to learn. Now, what we have learned, journey to the cloud. So we have talked about how we can start our journey to the cloud by understanding the fundamentals, and then learning some of the basic infrastructure, basic cloud environments like AWS, Azure, and Google. So we will be coming up with a lot of free sessions on AWS, Azure, and Google, both in English and Hindi. So you can find all those YouTube channel. And this brings to IT local, the local IT infrastructure to the global cloud infrastructure. So you can move your services from local infrastructure to cloud global infrastructure, and that is where public cloud comes into play. And we can have 5 characteristics of cloud computing, which are typically on-demand, broad network access, rapid elasticity, major services, as well as some pooled resources. These are the 5 characteristics of the cloud computing. And we have three different service models of cloud computing, which are typically infrastructure as a service, platform as a service, and software as a service. And four different deployment models of cloud computing, which are public cloud, private cloud, and the hybrid cloud. And we have just talked about how cloud is transforming the next generation telecom networks. And the next generation 5G networks are